I'm now going to talk about JSX. All web developers are comfortable with HTML, so allowing an HTML-like syntax in your source code while allowing the intermixing of JavaScript to provide any level of complexity to the dynamic parts of the content is a great solution. JSX was created by Facebook as a syntax extension to JavaScript for use with their framework called React, but it can be used with any framework that supports it. It requires a compiler pass to transform the JSX expressions into JavaScript that creates the described structure. Solid provides its own JSX compiler. When talking about the DOM structure, at first I wasn't sure if I should use the term node or element. I read that node is the generic term for any node in the DOM structure, while element is a more specific term for a node created by an HTML tag like div or button. I'm now going to show some JSX and how it gets compiled into JavaScript to demystify it a little. So babel.js.io has a try it out tab that shows how JSX gets compiled into JavaScript. So here is some code with a simple JSX expression. You can see on the right that the JSX expression that gets assigned to the foo variable is simply translated to a function call that'll create the equivalent DOM node. By default, React's createElement function is called to create the node structure. When this code executes, the resulting top-level node will be assigned to the foo variable. So I'll add this directive to tell this JSX compiler to use a different library to create the DOM nodes. So this, you can see that it's now calling my create element. This is not a real library. It doesn't exist, but you could implement it to customize your own node creation logic. I'm just showing that to show you that it's not married to React, and you can use it with any framework that supports it. And so when your build process is configured to use Solid, the JSX gets compiled into code that calls internal Solid functions to create the DOM node structure and implements the fine-grained reactivity logic. The node creation function takes 3 arguments. The first is the name of the HTML element, strong in this case. The second is an object that encapsulates all the element's attributes. And we don't have any attributes, so it's null in this case. And the rest of the arguments are the child elements. In this case, the string constant name, and that's the only child node. And JSX can appear anywhere a JavaScript expression is allowed, as a function return value, assigned to a variable, passed to a function, etc. The most common use case is in a component function that returns the JSX expression, or after JSX compilation, a function that returns a UI node structure. So here's a more realistic example of a function that returns JSX. And these examples aren't truly realistic. For example, they don't deal with state or accept properties, but I want to just focus on JSX for now. And so this is a component function, an arrow function, that returns a node structure. Once you define a component function, you can reference it in other component functions. Now this is a powerful feature. Here, label 1 is a simple component, but as you can imagine, this feature allows you to create very powerful custom components and reuse them anywhere. And so entry 1 is still an arrow function that returns a single expression. But it's recommended that you surround multi-line JSX expressions in parentheses to avoid issues with the automatic semicolon insertion. And this multi-line format makes it much easier to see the nested structure, and it has no impact on the generated code. And the generated code is a little hard to read, but you can see the nested calls to my create element And that's the benefit of JSX, a concise syntax that replaces code that's tedious to write if you use explicit node creation functions. So now let's add some attributes to a JSX element. And we'll use a JavaScript variable for the child text. So see that the ID and class attributes or properties are encapsulated in an object. So you can see over here when it gets translated into, when it gets passed as a second argument, all the properties are combined into a single object. This isn't that important. It's just good to know how it works. And you can see here that the child text node is taken from a JavaScript string variable. And when you specify a JavaScript expression instead of a string constant or something, you put it inside of braces. And any JavaScript expression can be placed inside of the braces. So here's another example where two functions are invoked to obtain values that are used by the component. And so this is a multi-statement arrow function, so it requires a return statement, and it defines two helper functions. When the label3 component function is invoked to render some part of the UI, the getClass and getText functions are invoked to obtain the the strong elements class and the child text node. And so this illustrates how easy it is to mix HTML-like syntax with JavaScript logic for the dynamic parts. And to keep the JSX syntax readable, it makes sense to move complex logic into helper functions that are invoked or referenced in the JSX. You'll see examples of this in a later section when we create an actual web application. And here's an example where the whole style attribute can be specified as either a string or an object. So here it's specified as a string. And you can see here that it's passed as a string and just gets directly translated. But it also supports, style also supports using an object literal to specify the style. And of course this object can contain multiple members to specify different styles. And when you pass an object literal to a component, the doubly nested curly braces are required. The outer ones are to indicate that this is a JavaScript expression, and the inner ones is to specify that this is an object literal. And JSX compiles to JavaScript calls that evaluate to a single JavaScript object. So this syntax is not valid. And that's because there's two nodes here at the same level, and there's no way to encapsulate that as a single node. So you have to wrap them in the special fragment syntax, which looks like an empty element. You see it immediately compiles once I get the syntax right. And so fragments let you group a list of children's and use them without having to add an extra top level node. So the fragment, you can see when it creates a top level node, it's a special kind of a thing called a fragment that doesn't get inserted into the DOM, but the children do. Now, to support fine-grained reactivity, Solid's JSX compiler does things a little differently with embedded JavaScript expressions than this compiler does, but there will be more on that later. So I hope this helped you understand JSX and how it's used in component functions, and we'll go into more detail on component functions next.